Welcome to this presentation by the International Fluid Power Society on understanding the dial caliper. My name is Dan Helgerson. In coming to understand the dial caliper, it helps to realize that there are at least three different types of calipers. There is the vernier caliper, the digital caliper, and the dial or analog caliper. In our discussion, we will be talking primarily about the dial caliper because once the functions of the dial caliper are understood, the other types can be easily explained. In this presentation, you will learn to recognize the parts of a dial caliper, understand how the dial caliper works, properly read a dial caliper, take outside measurements, take inside measurements, and take depth measurements. The 6-inch dial caliper is made up of a bar, and on that bar is imprinted a scale from 0 to 6 inches, and each one of those inches is then divided into 10 pieces so that each line represents 1/10 of an inch. There's a very fine rack gear that is embedded in the bar. On the far left, we have the fixed jaw, and then there is the sliding jaw, the bezel, the dial indicator or needle, thumb wheel, bezel lock, slider lock, and depth blade. We're now going to take a piece of that rack gear that we looked at before. We're going to explode a piece out, a piece that is really going to represent only 1/10 of an inch. On that rack gear is mounted a very small pinion gear. The pinion gear is sized in such a way that it takes one complete revolution to travel 1/10 of an inch. To get a better idea of exactly how that works, we will add the needle, and you can see that as the pinion gear moves, the needle travels one complete revolution as the pinion gear moves 1/10 of an inch. When we add the dial, you can see just how this works. As we move down the rack gear, the needle travels one complete revolution in the dial. And you can see that the dial is divided into 100 pieces. Now when we mount that back onto the sliding jaw, you notice that the needle is not now pointing to the 0. That's a problem because we need to make sure that we have zeroed this out or calibrated this so that it's correct. So the way you do that is you open the bezel lock, release that, and then you turn the bezel until the needle is pointing right to the 0, and then you tighten the bezel lock. Now your 6-inch dial caliper is ready to use. Different parts of the caliper are used for different types of measurement. The lower jaws are used for outside measurements, the upper jaw is used for inside measurements, and the depth blade is used for depth measurements. The reading point is our 0 point, and everything will be referenced from that 0 point. Now for every 1/10 inch of travel, the indicator travels one revolution with 100 reference points on the dial, so that every 10th inch is divided into another 100 equal parts, so that the dial indicator will give you an accurate measurement within 1/1000th of an inch. Next, we will take and read an outside measurement. To do this, we'll open up the jaws. And once we've opened them part way, let's take a practice measurement here to see just how we do this. The best way to do this is to first of all write down the number of inches that you see, then write down the number of tenths of inches that you see, and then write down the number of thousandths of an inch that you see off the dial. So here we go. How many inches have been exposed here? Well, we take a look and we see that it is just 1. So we'll write down 1.000. The next thing we're going to write down is the number of tenths beyond the inch that have been exposed. And we can see the number 2 that is there, but we cannot see the line where the 2 is, and so we're going to back up just a little bit and say that just only 1/10 of an inch has been exposed. We will write down 0.1 inches. The next thing we do is look at what the dial is saying, which is our 1,000th inch mark, and we see that it is at 92. So we write down 92, add these two together, and we have 1.192, or 1 192 thousandths of an inch. Now let's take an outside measurement. We have a cup that we're going to measure. We will bring the jaws in until it closes on the cup, and now we will do exactly the same thing. We see here that we don't have any inches exposed. We haven't arrived at the 1 inch, so we're going to write down 0.000, and now we need to look at where our reference point is. Our reference point, again, it's beyond 5, but it hasn't quite gotten to the 6, and so we're going to write down 0.5 inches. Then the next reading is going to be what the dial gives us. The dial is at 72, so we write down the 72, and we have a measurement of 0.572, or 572 thousandth of an inch. Now we want to take and read an inside measurement. So we're going to move our cup up above, flip it over, and now we want to close our dial and make sure that it's set at 0, and it is. We will bring the cup down so that the jaws can touch the inside, and then as we open it up, we come to the other side, and now we can take our inside measurement. We'll take exactly the same approach. How many inches are exposed? Well, none. So we write down 0.000. How many tenths of an inch are there? Well, I can see 1, 2, 3, 4. So we're going to write down 0.4 inches because we haven't quite exposed the 5. And the next reading, of course, is going to be the dial. The dial is at 94. We write down the 94, add those two together, and we have 0.494, or 494 thousandths of an inch. Lastly, we're going to take and read a depth measurement. So we'll take our cup and move it down to the other end. We're going to again re-zero out our dial. We'll move the cup into place, and then we will insert our depth measurement into the cup, and we find our depth measurement. Take exactly the same process here. We're going to take 3 different locations where we're going to find the numbers. How many inches are exposed? Well, clearly there are none, and so we're going to write down 0.000. How many tenths of an inch are there? Well, I see 1, 2, but I don't quite come to the 3, so we're going to have just 2 tenths of an inch. We're going to write down 0.2. And then what does the dial tell us? The dial is at 92, so it's 292. We add those together, and we have a measurement of 292 thousandths of an inch. So when we're taking a measurement, we take note of the number of inches, we take note of the number of tenths of an inch, then we take note of the number of thousandths of an inch on the dial. We add them together to get our reading. So you have now learned to recognize the parts of a dial caliper, understand how the dial caliper works, properly read a dial caliper, take outside measurements, take inside measurements, and take depth measurements. Now, when it comes to the other types of calipers, the vernier caliper, I just want to mention these, is the oldest and maybe the most reliable. It was invented by the French mathematician Pierre Vernier in 1631. The method of making external, internal, and depth measurements is identical to that of the dial caliper. This caliper consists of a main scale having increments of tenths of an inch, with a secondary scale, the vernier scale, that has one extra division within the same space. So for every 10 marks on the main scale, there are 11 marks on the vernier scale, and with practice, this allows the user to accurately measure to 1/1000th of an inch. The digital caliper is probably the most accurate and certainly the easiest to read. It is battery operated and electronically senses the relative position of the jaws. And the method of making external, internal, and depth measurements is identical to that of the dial caliper. They typically read to 3 decimal places, or 1/1000th of an inch, but as you can see, there is an additional digit that helps in rounding. The digital caliper does need to be zeroed out at each use, and if the battery goes dead, the user must rely on good vision to read the numbers. Thank you for watching. Look for more instructional videos from the International Fluid Power Society. Thank you.